What is our project used for? Our project is used to create a security wall for any business in order to access files with confidential information based on different clearance levels, allowing each person to only access files within their authorized domain. For example, a receptionist, you may only want that receptionist to have access to a first and last name, mailing address, contact number, contact email, but you may not want them to have access to information such as their banking account number, banking routing number, credit card information, social security, things of that nature. Why do we need to use this system? As the world continues to transition from storing paper with confidential information in locked cabinets, safe boxes with only authorized personnel with a key having been able to access that information, transitioning to a world where everything is becoming digital in clouds and so forth. This security wall creates that same illusion of a locked cabinet, of a safe box that only authorized personnel will be able to go ahead and access confidential information. So those that don't have a clearance level to access information such as social security, they won't be able to see that information. However, their authorized clearance levels will allow them to see a first name, last name, mailing address, contact number, and email. In the next couple slides, we're going to be going over what was used to make the system. On the front end development, we used HTML. For our security systems, we used Java. For our login page design, we use CSS. For our store website and allowing the public to have access to this actual site, we use OSLite, just as we would for FIU sites. And last but not least, we also used Word for images and creating these files for the security clearances on what's to be seen and shown for clearance 1, clearance 2, all the way up to 7.
Hello everyone, my name is Elijah King, and the first slide that I would like to present to you is the purpose of the login page. The purpose of the login page is to allow users to log in to their account. At this level, we split the levels of security by security clearances. This is also where one of our future implementations will begin, which is data reports on different items such as time accessed, files accessed, and also unauthorized file access attempts. The next topic we will be speaking about is what do the different user accounts let you do. The easiest way of explaining this is it gives you access to different files. Going on to a more detailed perspective, each user has a security level of 1 through 7, 7 being the highest security clearance, 1 being the lowest. In our case, the security clearances in order are public trust, confidential, secret, top secret, top secret SCI, special access program, and Yankee White clearance. These clearances allow you to access files depending on the sensitivity of the information. Continuing on, one question you might ask is why can users with higher access multiple file locations? The reason for this is because a person with a top secret clearance has a higher security clearance than the previous 3, allowing them to be able to see all files that are within them, as a top secret clearance is more restrictive on what is inside of it than the previous 3 security clearances. This is why a user with a Yankee White clearance is allowed to see all clearance levels files, as it is the highest security clearance level in our system. Going on to the next slide, how did we create the different security levels on the project? The first step was to create the users. After creating these users, you can see we gave each user an access level from 1 through 7. 7 being the highest and 1 being the lowest. We used these numbers in each button for each clearance. So if you're trying to access the secret file button, the parameters are to have an access level of 3 or higher, or you will not be able to access the files. When a user clicks on a button that they do not have the access levels for, they get redirected to an error page. Going on, I will be speaking of the type of alerts that can be implemented into our page. The types of alerts that can be implemented in our page are email communications to all superiors, text communications to all superiors, and live admin alerts, breach of security alerts, and logs of all logins that have happened on the website. The reason it is important for these is to allow companies to monitor what their employees are doing and to make sure that they are not trying to access information that they should not be accessing. In this slide, I'll be speaking about the target audience. The target audience for us specifically are accounting firms, medical providers, government jobs, transportation jobs, and the aviation industry. The reason for this is because it best suits our website as we have different levels of security on it, and most of these types of jobs would have also a level of security built within them that allows us to implement our technology into their business. How can we modify the project to fit your business? This project can be modified to be able to handle multiple things for a business. Some things that we could do is handle confidential files, payroll, accounting, employee records, and further things that have different levels of authority for a business. In this slide, I will be covering the data flow chart. The data flow chart is a simple way of seeing how our website is built. As you can see at the bottom right, we have employee A, employee B, employee C, and a manager up top. This manager is then connected to an admin who has total control over the system and is able to see different things, like when a person accessed a certain file and how long they have accessed this information. Going further on from that admin, we have the vice president, the president, and these are higher authority over the admin. Specifically, these could be CEOs or different individuals that own a company.
How data collected is used to produce benefits. The data our intruder alert system collects is key to improving both security and operational efficiency. This data includes login attempts, user activity, and access logs. By analyzing these points, the system helps identify unusual behaviors such as repeated failed login attempts or access from unexpected locations, which might signal potential security threats. Beyond security, this data enhances organizational performance in 3 critical areas: time management, file management, access management. By identifying these inefficiencies, such as the slow response times to alerts, businesses can streamline workflows, saving time and resource. This slide highlights the key costs associated with implementing our intruder alert system. These costs are divided into 5 main categories. Server cost. This includes the expense of acquiring and maintaining the servers needed to store and process the system's data. Security features. These are investments in encryption, authorization, and mechanisms and other technologies to safeguard data and prevent breaches. Regular updates and penetration tests also fall under this category. Development cost. This encompasses the time and resources spent on coding, testing, and deploying the system. This also includes salaries for developers and engineers. Website design cost. If the system includes a web-based interface, designing and maintaining a user-friendly website incurs additional cost. And lastly, domain name. For systems that require online presence, the cost of purchasing or renewing a domain name is another factor. Types of analytics. This slide outlines the key types of analytics that our system uses to provide valuable insight and improve security. Files access. This system keeps a log of which files accessed and by whom. This ensures transparency and helps detect unauthorized access to sensitive documents. Time on website when logged in. By tracking how long users remain logged in, we can identify unusual behaviors such as excessive long or short sessions, which might indicate potential misuse or errors. Unauthorized access attempts. The system tracks failed login attempts or attempts to access restricted areas. This helps identify potential breaches or areas that might need stronger security measures. Information access. This tracks what specific data or section users are interacting with, ensuring sensitive information is accessed by authorized personnel. Amount of users trying to access the page. Monitoring traffic to the system helps identify spikes that could indicate distributed denial of service, DDoS attacks, or an unusual increase that needs an investigation. How the analytics helps the client. Analytics plays a crucial role in enhancing the functionality and security of systems for our clients. By processing the data collected, the system provides actionable insights that improve decision making and security measures. Monitor file access. Analytics tries which files are being accessed by whom. This helps ensure that sensitive data is only viewed by authorized personnel and detects any unusual and unauthorized access attempts, accessing user activity. By analyzing user behavior such as login times and session durations, the system helps identify patterns that indicate normal versus suspicious activity. Detecting unauthorized access attempts. The system uses analytics to identify failed login attempts or other behaviors that could signal an attempted security breach. These insights allow for proactive measures to mitigate risks. And lastly, tracking access volume. Monitoring the volume of users accessing the system at any given time helps in detecting anomalies, such as hidden surge and access attempts that might indicate a DDoS attack. Vulnerabilities. This slide highlights some key vulnerabilities that organizations must address to maintain the security and integrity of their systems. Lower clearance level accessing unauthorized levels. Users with insufficient clearance may attempt to access restricted files or areas. This vulnerability can be exploited if proper access controls aren't enforced. Editing of documents. Unauthorized or accidental editing of sensitive documents can compromise data integrity and lead to operational disruptions. Downloading of documents. Sensitive files could be downloaded by unauthorized users, increasing the risk of data leakage and breaches. Weak points in the system, such as poor encryption or inadequate monitoring, can be exploited by attackers to gain unauthorized to confidential data. And lastly, phishing. Social engineering attacks like phishing emails trick users into divulging credentials or accessing malicious links, exposing systems to external threats. Problem of solving current challenges. This slide highlights the challenge. Ensuring robust access control. One major challenge is managing access levels to prevent unauthorized entry or misconfigured permissions. If a user has more access than they need, it increases the risk of data breaches. To address this, we implement strict role-based access controls and conduct regular audits to ensure permissions are aligned to job responsibilities. Handling unauthorized access attempts. Another challenge is identifying and stopping repeated or sophisticated unauthorized access attempts. We tackle this through advanced analytics to detect anomalies, combined with real-time alerts that allow administrators to take immediate action. Scalability of program. As businesses grow, the number of users and files in the system increases. Ensuring that the system can handle growth without compromised performance or social or security is critical. We designed the system to be modular and scalable with infrastructure that adapts to increasing demand while maintaining speed and reliability. Privacy issues. Data breaches. Websites and systems are vulnerable to cyber attacks, increasing the risk of data breaches. Attackers can exploit weak points, leading to exposure of sensitive information. Non-compliance of regulations. Failure to comply with privacy regulations such as GDPR can result in significant legal penalties. Non-compliance can also lead to inadequate privacy practices where users may not be fully aware how their data is being stored, shared, or protected. And data collection. Excessive or unnecessary data collection can create risk and unauthorized access, especially if proper security measures are not in place. Collecting only the data required and ensuring it's securely encrypted minimizes these risks. To address these challenges, organizations must prioritize robust data security measures, clear communication about data use, and adherence to privacy laws that maintain both compliance and user trust.
Hello, my name is Luis Salazar, and let's start with mitigation strategies. To enhance system security, one of the most important steps is conducting regular penetration testing. This helps to ensure that our system remains robust against external threats by identifying vulnerabilities early on. We can mitigate risk effectively and maintain the integrity of our systems. Adherence to established standards and regulation is crucial. Under data security standards, we have the ISO IEC 27001, which sets the requirements for an information security management system. Additionally, the NIST or NIST cybersecurity framework provides best practices for identifying, protecting, detecting, responding to, and recovering from cybersecurity threats. On the privacy side, we comply with regulations like the GDPR for our European clients and the CCPA for the US based clients. These frameworks and regulations form the backbone of a secure and compliant environment. Why is it essential to build these security measures? First and foremost, for data privacy and to protect against attacks. It's also about maintaining a good reputation. Clients trust us to safeguard their data. Security measures are cost effective in the long run as they help avoid potential breaches. Plus, a secure system ensures a seamless user experience while contributing to overall security. Looking ahead, we plan to introduce features that enhance security and user experience. This includes business security enhancements, efficient file distribution systems, organized security levels, and detailed data reports. Each of these features adds another layer of functionality while maintaining security as a priority. Future developments will also focus on collecting detailed data regarding login attempts. These include recording the date and the time of user logins, tracking files access, and monitoring user login details. These insights will help identify potential security issues and improve system functionality. Here's what we aim to add in the future: time tracking for server access, periodic sign or check-in for users, Face ID access for enhanced authentication, live user monitoring for administrators, advanced database management, and integrated cloud storage. These upgrades will ensure a more robust and user-friendly system. Thank you for your time and attention. We will gladly answer any questions that you guys have.